In this lesson, we will discuss the basic concepts for creating and working with lists in Dynamo for Revit and Dynamo Studio. A list is a collection of data or elements organized in a specific order. Let's begin by searching for the number sequence node. The number sequence will create a sequence of numbers. To define its input, start, amount, and step, I will use number nodes. Connect the output of the number node to the start input to define the starting value of the sequence. I will then repeat the process with two more number nodes to define the amount of values in the sequence as well as the step increment. Let's increase the amount to 10 and the step to 1. Clicking on the rectangle in the lower right corner of the number sequence, I will see a pop-up indicating that there is an empty list. By pressing Run, we will execute the command. Let's now search for the number range node. The number range node creates a sequence of numbers in a given range. I will use more number nodes to define its inputs. Connect the first node to start input, the second node to the end input, and the third to step. Let's start at 0, end at 10, and step by 1. I will click on the rectangle at the lower right-hand corner of the number range node to display its output. Again, we need to press Run to recalculate our new values. Clicking Run automatically will allow us to see the changes we make reflected automatically. Let's now look at how we may use the number node to define sequences. Search the node library for number to add a new number node to the workspace. Using a watch node, we can display its output. In the number field of the number node, type 0.10 and hit enter. This will result in a list of values beginning at 0 and ending at 10. The step between the values is by default 1. If changes are made to the number node, changes are reflected dynamically in the watch node. Changing the end value to 6, we will see we now have a collection of 5 values beginning at 2 and ending at 6 and incrementing by 1. Let's copy and paste the number and watch nodes to see what other sequences we can define using the number node. By adding ..#10, we will see we have a list starting at 2, ending at 6 with a total of 10 values. Remember that the first index in a list is 0, therefore the last number in the index is 1 less than the number we defined in our total count. Let's copy and paste the number and watch node one last time. This time I will swap the hash for a second number. This will result in a list that starts with 2, contains 6 values, and increments by 10. Let's use the string modifier start, end, and count to define a sequence of points. I will search for the point XYZ node and add it to the workspace. Let's connect the watch output port to the X input port of our point by coordinates node. Clicking on the rectangle at the bottom right corner of our node, we will see a list of points. To view these points, let's turn on the background 3D preview. Remember, to navigate to the background 3D preview, you can simply hit Ctrl B. Let's change the start value in our sequence. Let's now change the total count. I will collapse the node by clicking on the rectangle again. Notice the icon at the bottom right of the point by coordinates node. This indicates the lacing for the particular node. Lacing determines how the input port should use the incoming data. By right-clicking on the XYZ node, I can access the lacing options shortest, longest, and cross product. By connecting the output of my watch node to the Y input, we will see we now have a diagonal list of points. By right-clicking and changing the lacing option to cross product, we now have a grid of points. Lacing operations are important components to effectively working with multiple sequences of data. For instance, if you need to construct a sequence of line segments, you would need to create more than one collection of points. I will right-click on my point by coordinates node and change the lacing back to longest. I will disconnect the Y input port and replace it with a number node. I will also use the number node to define the Z port input. Let's copy and paste our nodes and create a list of lines by start and end points. I will type line into the search field of the node browser. My top result is by start and end point. Connecting the output port of my first point to start and the output of my second point to end, I will receive a warning from Dynamo. By mousing over the balloon, I will see there is a warning stating that a line cannot be created because the lines are coincident. I will copy and paste the number node and define a new Z value. By increasing this value and pressing enter, I can now see the display in the background 3D preview update. By changing the count value in the number node, we will now see that we have an uneven number of points at the top and bottom. By right-clicking on the line by start point and end point node, I can change the lacing option from shortest to longest. This more clearly illustrates the way in which Dynamo is computing this particular solution. The last point in the shorter list is executed on for the remaining items in the longest list. By right-clicking and changing the lacing option back to shortest, we will see that the shortest list is no longer going to execute the remaining elements in the longest list. By right-clicking and changing the lacing option one last time to cross product, we will see that all solutions will be computed. Let's go ahead and set the lacing back to longest. To make sure we do not end up with two lists of varying lengths, I will delete the number node defining my endpoint. I will use the same number node for both my start and end. By making the changes to either of these values, the start or the end, we will see that the list will update and the background 3D preview will display the results. With the correct number of lines being computed, I would like to see if I could use a mathematical function to change the character of our segments. What I would like to see is the effect of modulating the lower point sequence using a sine function. The sine node is located in the Core Math Actions category. The input port of the sine node is labeled angle. I'll put my mouse over the port to see what type of data this port requires. Because the data input requires the data be in degrees, I will need to find a node to convert my sequence of values from radians to degrees. Looking through the list of nodes in the math category, I will see there are nodes called degrees to radians, and you will also see radians to degrees. We will choose radians to degrees to add the node to our workspace and connect the output of our watch node to the input radians. The output of radians to degrees will connect to the angle input of the math sine node. I will now connect the output of the math sine node to the y input of my points by coordinate node. To add a little more interaction to our definition, let's look at an interesting feature of the number node. Strings used to define a sequence in a number node can be modified to include variables. I'm going to replace the count value with the variable a. In doing so, an input port is added to the number node. We can now connect an integer slider to this port to quickly change the number of points computed. I will take the output port of the integer slider and connect it to the A input port of the number node. I can now make changes on the fly and see the background 3D preview display in real time.